Hi everyone, welcome to Think Academy's middle school challenge questions. Now without further ado, let's go ahead and look at the questions. So in the first one, we have a really long expression. So we have 1 over 1 multiplied by 3 plus 1 over 3 multiplied by 5 goes on and go to 1 over 2019 multiplied by 2021. So it might look a little scary, but as long as you can find the patterns, it's gonna be really easy to solve. So in the first term, we have 1 multiplied by 3 in the denominator. And in the second term, we have 3 multiplied by 5 in the denominator. And goes on to the last term, we have 2019 and 2021 in the denominator. Do you notice any patterns? Well, the first patterns we have is that the difference between the two numbers is always 2. So the difference between the two numbers is always 2. And the numbers are consecutive. So we have 1 and 3 in the first term, and we have 3 and 5 in the second term. And we see that the 3's are the same. So the numbers are consecutive. That's the two patterns we have. And how can we use the two patterns to solve this question? Now we can rewrite the first term as 1 over 2 multiplied by 1 over 1 minus 1 over 3. Why do we have a 1 over 2 in the front? That's because the difference between the two numbers is 2. That's why we have 2 in the denominator. And then inside the parentheses, we just have 1 over 1 minus 1 over 3. Both 1 and 3 are in the denominators. So now that's the first term. The next term, we have 1 over 2 because the difference is always 2. And then multiply by 1 over 3 minus 1 over 5. And goes on. In the last term, we still have 1 over 2 because the difference is always 2. Multiplied by 1 over 2019 minus 1 over 2021. Okay? And now you see that we have a 1/2 in each term. So 1/2 is the common multiple. We can pull out a 1/2 and use a parenthesis to represent everything inside. So we have 1 over 1 minus 1 over 3 in the first term. In the second term, we have 1 over 3 minus 1 over 5. And goes on until the last term, we have 1 over 2019 minus 1 over 2021. Okay? And you see that we have a minus 1 over 3, and we also have a plus 1 over 3. That means we can cancel them out. And same goes for 1 over 5 and goes on to 1 over 2019. So we can cancel out all the terms in the middle and only left with the first term 1 and the last term minus 1 over 2021. So we can simplify this expression into 1 minus 1 over 2021. And then it's going to be really easy. We just do some arithmetic, and the result is 1010 divided by 2021. So we see that we can use the patterns to solve this question. Now for the next one, again, we have a really similar patterns here. So in the first term, we have 2 and 5, and the difference is 3. You notice that the numerator in this fraction is no longer 1, and the numerator equals the difference between the two numbers. Well, is that the same for all the terms? We'll check it out. So in the second term, we have 5 and 7, and the difference is 2. The next term, we have 7 and 11, and the difference is 4. So we see that the patterns goes on till every term. So then we can rewrite the first term into 1 over 2 minus 1 over 5. We no longer need a multiple before the parentheses because the numerator equals the difference between the two numbers. So we have 3 over 3, which is 1. So we can drop out the common multiple. And the same for the second term, we have 1 over 5 minus 1 over 7, and 1 over 7 minus 1 over 11. And we can go on until 1 over 44 minus 1 over 50. Okay, and again, everything in the middle will cancel out. And we are only left with the first term, which is 1/2. And the last term, 1 over 50. And remember, we have a negative sign. So that equals to 24 over 50, which is 12 over 25. And that's the answer to this question. Now for the next one. The solution of this equation, x over 2 plus x over 6 plus x over 12 and plus x over 2020 multiplied by 2021 equals to 40. How do we solve this equation? So the left-hand side contains x, but it still has a similar format as the previous two questions. So you can get a hint from the last term because it's a product of two numbers, 2020 and 2021. Although it's not shown in the first few terms, but 2 is actually 1 multiplied by 2. 6 is 2 multiplied by 3, and 12 is 3 multiplied by 4. So we still see the patterns that the numbers are consecutive and the difference between the numbers are the same across all the terms. So the first term can be rewritten as x multiplied by 1 over 1 minus 1 over 2. Again, because the difference is 1, so it's just x over 1. And then we have plus x multiplied by 1 over 2 minus 1 over 3. Because in the denominator 6 is just 2 multiplied by 3. And goes on until we have 1 over 2020 minus 1 over 2021. And because we have an equation, so don't forget on the right-hand side, we still have a 40. Okay? Now, because they all have a common multiple of x, so we can pull out an x, and x will be 1 minus 1 over 2 plus 1 over 2 minus 1 over 3, and then goes on until 1 over 2020 minus 1 over 2021. And the whole thing equals to 40. Okay? And again, all these terms will cancel out, and we are left with only the first term, which is 1, minus the last term, 1 over 21. That equals to 40. And then you are able to simplify this equation by finding the common denominator, which is 2021, and then do the arithmetic in the numerator. So we get 2020 over 2021 multiplied by x equals to 40. And we can just divide both sides by 2020 over 2021, and the final result will be 42. So that's the answer to this question, 42. Okay, now for the next one. If the solution to the linear system, so we have a linear system here, and we have 3 equations in the linear systems, and we know that this linear system can also satisfy the equation 3x plus 5y minus z equals to 27. Then what's the value of k? Now if we first look at the linear system, and if we treat the k as a parameter, that means k can be treated as a constant. Then we are only left with 3 variables and 3 equations. That means we can solve the values of x, y, and z. So let's do that. We first have the linear system, x plus y equals to 2k, and y plus z equals to 3k, and z plus x equals to 5k. And let's say the first equation is equation 1, the second one is 2, and the third one is 3. Now we first use 1 minus 2. What do we got? On the left-hand side, we have x plus y minus y plus z. And on the right-hand side, we have 2k minus 3k. And the y will be cancelled out, so we are left with x minus z, that equals to negative k. So that's the result if we use equation 1 to subtract equation 2. Then let's say the new equation is equation number 4. Now we want to use the equation 4 and add equation 3. So equation 3 add equation 4. What do we got? In equation 3, we have z plus x. And in equation 4, we have x minus z. And the right-hand side will be 5k minus k. And the z will cancel out, so we have 2x equals to 4k. That means x is 2k. Now if we know that x is 2k, we can plug in the value of x into equation 1 and equation 3, and we can solve for y and z. So let's do that. We plug in the value for 2k, then x plus y equals to 2k. That means 2k plus y equals to 2k. So y equals to 0. So that's the value for y. Now for z, we have z plus x equals to 5k. And x is 2k, so z plus 2k equals to 5k. That means z is 3k. Okay? So we find the values for x, y, and z. Now the last step is to use the final equation. 3x plus 5y minus z equals 27. We just plug in the values of x, y, and z into this last equation. So we have 3x plus 5y minus z equals to 27. And what's x? X is 2k. So 3 multiplied by 2k plus what's y? Y is 0. And 5 times 0 is just 0. And minus z, which is 3k. That equals to 27. And then we have 6k minus 3k equals to 27. And k equals to 9. So the value of k is 9. So again, we can just first solve the linear system for x, y, and z. And then we are only left with the one variable, which is k. Then we can plug in back into the last equation, and we can solve for k. Now for question number 4, we have a word problem. A boat can travel 80 kilometers downstream in 4 hours, and can travel 96 kilometers upstream in 6 hours. Assume that the boat travels at a speed of x kilometers per hour in still water, and the speed of the current is y kilometers per hour. What's the speed of the boat in still water, and what's the speed of the current? So now we already assume that the speed of the boat in still water is x kilometers per hour, and the speed of the current is y kilometers per hour. Let's imagine ourselves sitting on a boat in the river. So here's the river, and the current has a direction. So let's say the current is from left to right. That's the current. And we are sitting in a boat. Suppose we are traveling downstream. That means we are traveling at the same distance as the current. So what's our total speed? The total speed should be x plus y, because with the help of the current, we are able to travel faster. So x plus y is the total speed if we are traveling downstream. But if we are traveling upstream, that means we are traveling against the current. The current is still from left to right, but now we are traveling against the current. So we are traveling from right to left. So what's our total speed in this case? The total speed is actually x minus y, because the current is slowing us down. We are traveling in opposite direction, so the total speed should be x minus y. Now we can create our linear system. In the first case, the boat can travel 80 kilometers downstream in 4 hours. That means the time is 4 hours, and the speed is x plus y kilometers per hour, and the total distance is 80 kilometers. And in the second case, we have time is 6 hours, the speed is x minus y, and the total distance is 96. We can first simplify both equations. So in the first equation, we can multiply both sides by 1/4. That means on the left-hand side, we only have x plus y, and on the right-hand side, 80 divided by 4 is 20. And again, for the second equation, we can divide both sides by 6. So we have x minus y in the left-hand side, and on the right-hand side, we have 96 divided by 6, which is 16. Now it's easy to solve for x and y. So x is actually just 18, and y is 2. So we know the speed of the boat in still water is 18 kilometers per hour, and the speed of the current is 2 kilometers per hour. And that's it for this question. Now for the last one. A school plans to plant some trees in the campus. The school wants to buy a total of 60 saplings of A and B. The price of each sapling of A is $60, and the price of each sapling of B is $40. Assume that the school buys X saplings of A and the total cost is Y dollars. So what's the equation of the relationship between Y and X? And what's the range of X? Let's first look at the first part of the question. What's the equation of the relationship between Y and X? Now suppose the school buys X saplings of A, and we know the total number of saplings is 60. Then what's the number of saplings of B? So we know A is X, and the total number is 60. So B is just 60 minus X, right? Now we have the number of saplings of each kind. We can find the total cost. The total cost, which is Y, equals to the number of A, which is X, and the unit price is $60. So we have 60X plus the unit price for B is 40. And the number is 60 minus X. And simplify the answer, we got 2400 plus 20X. So that's the equation of the relationship between Y and X. Now what's the range of X? We know X has to be greater than or equal to 0 because X is a number of saplings. We cannot have a negative number of saplings, right? But then what's the upper limit? X shouldn't be greater than 60 because 60 is the total number of saplings. So we cannot have more than 60 saplings of A. So that's the range of X. Now for the second question, if the amount of saplings of A is not less, so what's not less? Not less is greater than or equal to, then twice that of saplings of B. Find out a solution that the cost is the least and calculate the total cost. So in the first half, we have an inequality because we have the greater than or equal to. And we know that the amount of saplings of A, which is X, is greater than or equal to twice that of saplings of B. So 2 multiplied by 60 minus X, because 60 minus X is the number of saplings of B. Now we have the inequality. Let's do some simplification. So we have X greater than or equal to 112 minus 2X. That means X is greater than or equal to 40. And in the previous question, we know that X should be greater than or equal to 0 and should be less than or equal to 60. So the new range should be 40 from 60. So that's the new range of X. And then we need to find a solution that the cost is the least. Now we know Y equals to 2400 plus 20X. This is the equation of the relationship between Y and X. And you notice that because the coefficient before X is positive, when X increases, Y will actually increases, right? If we don't have any saplings of A, then total cost is going to be 2400. If we have one saplings of A, then we add $20 to 2400 and we have a greater cost. So as X increases, Y will also increase. So the least cost occur when we have the least amount of saplings of A, which is 40, because 40 is the lower limit. So we plug in the value for 40, and we get the least cost is 3200. So the least cost occurs when we only have 40 numbers of saplings, and the least cost is 3200. So that's all for the questions. Thank you so much for your time, and I look forward to seeing all of you in Think Academy. Thank you.